Hello, my name is Shiva. Today we're going to look at an interesting physics problem. So a projectile is really an object that's thrown, some angle with respect to the ground. You throw a ball, it becomes a projectile. Launch a rocket, it's a projectile. So the question is, given that you can launch that projectile with initial velocity v, right? That's the maximum, say, velocity you can launch it at. What is the maximum height it could get to? And what is the maximum distance horizontally it could get to? And what is the relationship between those two distances? So forget about math, just try and visualize it. If you have a ball, right, what's the maximum height it can get to? Clearly you want to throw it straight up, right? You don't want to throw it at an angle because that'll make it go far rather than high. So just imagine you threw it straight up, right? How far could it get? Say you were able to get it 30 meters high. You're a strong guy and can overcome gravity for a bit. Get it 30 meters high, that comes falling down. That's the maximum you could throw it to, height you could throw it to. Now say with the same velocity, meaning the same force, you threw it at some angle, maybe horizontally, maybe at I don't know what, some angle, so that it went some horizontal distance. The question is, how far could you make it go? If you could throw it 30 meters up, right? What's the maximum horizontal distance you could get? Would it be equal to 30 meters? Would it be more than 30 meters? Would it be less than 30 meters? And if it's if it's less, how much less? If it's more, how much more? Will be pretty close. Can you kind of justify that answer? So it's perhaps not too hard to get the right answer, but it's definitely not easy to visualize and come up with an exact answer of what the relationship between those two maximum vertical heights and maximum horizontal heights should be. So again, math comes to our rescue, and we're going to kind of carry out a rigorous analysis to see what the relationships between those two are. So first, let's get the maximum height. So say you're throwing this ball up, right, with that maximum velocity v. That maximum height it gets to is h. Say it has mass m, and the acceleration due to gravity is v. Now, we can do this using Newton's equations, and we'll come to that in a second, but what's that maximum height that's reached? Well, a very easy way to come to the answer is to notice that all the kinetic energy that's initially in the ball, remember, energy is conserved, it's constant, and initially the ball has only kinetic energy, assuming, where, say there's zero kinetic energy at the point we're starting from, and, it's just a reference point, so it doesn't matter what we have. So say, initially, all the energy in the ball is kinetic energy, which gets transformed into potential energy as you go up to the highest point, where it's not moving at all. The kinetic energy is zero, and the potential energy is maximum. So by equating the kinetic energy at the bottom and the potential energy at the top, we can actually find what the maximum height is. We know kinetic energy, KE, equal to P, at the bottom and at the top. Kinetic energy, and this comes from the fact that energy at the bottom equal to energy at the top. And it just so happens that energy at the top is all potential energy, so KE is 0 here, and energy at the bottom is all kinetic energy. And energy equal to kinetic energy plus potential energy. Kinetic energy at the bottom is half mv squared mass times velocity squared. And potential energy at the top, we know there's a formula, mgh. Mass times acceleration due to gravity times h. So cancelling out, we get h is equal to v squared by 2g. So really this is the maximum height that can be achieved by the projectile. Again, we made use of the kind of common sense fact the maximum height is going to be attained if you throw it vertically up. But just to, just for sanity checking to make sure that we've done this correctly, let's also use Newton's equations. So we have Newton's equation that says the final velocity squared equal to the initial velocity squared minus 2ah. A is the acceleration, in this case it's g, acceleration due to gravity. The sign is negative because, and notice here I used v for the initial velocity, here I'm using it for the final velocity, so don't let that confuse you. The final velocity is the initial velocity minus the negative sign because acceleration is pointing down to slow the ball down. It's working opposite the direction of the initial velocity. And we know the final velocity is 0. The initial velocity is v, in our case we're using that same v squared. So we have v squared equal to 2gh, which implies h, taking it that side, equal to v squared and then dividing by 2g, which is the very same result we got. Alright, so we know that given that the maximum speed at which you can throw the projectile, launch it, is v, the maximum height occurs when you project it directly upwards, and the maximum height is v squared by 2g, where g is the acceleration due to gravity, which is a constant for our practical purpose. It will vary a little bit as the height changes, but for a simple problem we just assume it's constant in that region. Alright, so let's store this result, and now look to find the maximum horizontal distance. Remember, h is v squared by 2g. So I'm going to store this in the top right corner, and we'll come back to later to see what the relationship between the maximum horizontal and the maximum vertical distance is. So now clearly, to get a horizontal distance, we want to throw the projectile at some angle theta. In other words, we're still going to project it at its maximum velocity v, right? But it's going to be at some angle theta with respect to the x and y axes. So we're going to break the velocity down into components. We have the horizontal component, which is v cos theta, and the vertical component, which is v sin theta. Our plan of attack is as follows. We're going to use the vertical component, v sin theta, to really find out how long, for this general angle theta, it's completely general right now, it could be any value, how long that projectile stays in the air. Once we know how long it stays in the air, all we have to do is multiply the time it stays in the air by the horizontal component, because it's really moving horizontally for that much time to get the distances traveled. Now that answer is definitely going to be in terms of theta, right? So once we do that, we will try and maximize that value. We'll maximize the value by taking a derivative, setting it to 0, to find the value of theta for which it's maximum, and then find the corresponding maximum horizontal distance. So that's the plan of attack. So let's see. The same way we carried out Newton's equation, v squared equal to u squared minus, well, we don't want to use that. We want to do v equal to u minus at. Here acceleration is operating against the initial velocity. This is the final velocity, this is the initial velocity. Acceleration is operating against it. This is Newton's first equation of motion. Here a is g, acceleration is g. Now this time is really the time it takes to get to the highest point. So when we're going to calculate the time of flight, it will be twice the small t, the time to the highest point, which is the same as the time it takes to go down, right? Because, by symmetry, but like speeding up, slowing down, speeding up, it's really the same thing. And in this case, our initial final velocity is 0. At the topmost point, there's 0 velocity, it stops for a bit. The initial velocity is that vertical component, v sin theta minus gt. So in other words, t equal to v sin theta by g. Or in other words, the total time is going to be 2v sin theta by g. So this is the time that the projectile is going to be in the air for a given angle theta. It makes sense that it would depend on the angle theta, right? Throw it at a different angle, it'll be in the air, it'll reach the ground at a different time. Now, we want to see what the total horizontal distance covered is. But that distance, h let's call it, is nothing but time it's in the air times the horizontal component of the velocity. Distance equals speed into time. Speed into time. It's a neat trick. So, and that would give us 2 v v squared, just multiplying these two, v squared sine theta cos theta by g. So really, we want to find the value of theta for which this is maximized. In other words, we want to find a maximum value of cos theta sine theta and then compare this expression with this expression. But notice how similar they look. There's a v squared by g, a factor, and then there's this value. But the maximum value that this contains is definitely going to be some numerical value. So we really see that the horizontal distance maximum horizontal distance, and the maximum vertical distance are really going to be some multiple of each other because the variables v and g are going to cancel out. So let's go and find how to maximize sine theta cos theta. Just going to make a little. The way we do that, simple calculus, is by taking the derivative with respect to theta and setting it equal to 0. Sine theta cos theta equal to 0. Now, using the product rule, this is sine theta times the derivative of cos theta, which is negative sine theta. We get negative sine squared theta plus cos theta times the derivative of sine theta, which is cos theta, so cos squared theta equal to 0. Or in other words, sine squared theta equal to cos squared theta. Or sine theta equal to plus minus cos theta. But this really happens for theta between 0 and 90 degrees when theta is 45 degrees, because then sine 45 is 1 by root 2 and cos 45 is 1 by root 2. So this really implies for theta between 0 and 90 degrees that theta would be 45 degrees. And that kind of makes sense, right? If you want a maximum horizontal distance and you have to guess what angle you have to throw it at, what would you guess? Well, the answer is 45 degrees, and if you guess that, great. So theta is 45 degrees maximizes sine theta cos theta, in which case this becomes 1 by root 2 into 1 by root 2. 1 by root 2 times 1 by root 2 is 1 by 2. So we get 2v squared by g into 1 by 2. The 2's cancel and we get v squared by g. So if you compare the maximum horizontal distance v squared by g to the maximum vertical distance v squared by 2g, you see that the maximum horizontal distance is actually twice the maximum vertical distance. So h max equal to 2v max. So this is a very interesting result. I wonder if anybody could, without doing the math and without having seen this problem before, actually visualize it. Actually, just imagine throwing a ball completely up in the air, straight up in the air, and throwing a ball at a 45-degree angle, and really visualizing that the maximum horizontal distance it could travel is really twice the maximum vertical distance it could reach. So it's a very interesting result, and here's the rigorous math that actually proves that it works. Hope you enjoyed it. Thank you.